Okay, listen ma. So in this topic we are going to calculate what kind of velocity possessed by satellites. So consider a satellite whose mass is m, which is revolved around our earth surface. So earth mass is m, listen, earth mass is m, earth radius is r, earth center point is o. This is nothing but an orbit. Over this orbit only satellite is revolving. So over this orbit only satellite is revolving. So satellite location from the earth surface is nothing but h. Can you say what is h? Distance between a satellite from earth surface. From earth surface satellite is located at a distance of h. From the center of the earth satellite is located at a distance of r plus h, which is nothing but small r. What is capital R? Radius of earth. What is okay, satellite mass is m, earth mass is capital M. I asked you sit there itself. Keep this pen here. Okay, I will give. Okay, now small r is nothing but capital R plus h. This satellite revolving in circular orbit means actually any object revolves in circular path means it requires centripetal force. So the necessary centripetal force equation mv square by r, centripetal force obtained from gravitational force which is exist between earth and satellite. Gravitational force formula g m1 m2 by distance square. Here m1 m2 is nothing but mass of earth and the mass of satellite. Distance between the earth center and the satellite is nothing but small r. After cancelling small r, small m, we are getting v square formula as g capital M by small r, or v is equal to root over gm by small r. Again this small r can be replaced by r plus h. If any satellite revolves very closer to the earth surface, we know very well radius of earth is 6,400 km. If any satellite is revolved very closer to earth, very closer to earth means around 400 km. So in the case of polar satellite, you know what are polar satellite? Satellite revolves through north pole and south pole in vertical plane, that is called as polar satellite. All the polar satellite actually available short height from the earth surface. Ella polar satellite to earth surface on the short height around 300 km to 400 km. Within that range only polar satellite will be available. So in that scenario we can say h is very small. Here I have considered h is tends to 0, but h will not. Girl, what are you doing? Whether here class is going or some other thing is going. எடுத்து எரிஞ்சிரையும் பார்த்துக்கோ. Don't know how to behave inside the classroom. Sit. So in such a case, h can be neglected. So the further equation becomes gm by capital R. We know very well gm by r square is nothing but small g. Am I right or not? Gm by capital R square is equal to small g. Now this r is splitted in this manner means by taking one r value this side, gm by capital R will be equal to small g capital R, so that gm by capital R is replaced by g into capital R. So what is v? Velocity of satellite. Its first equation root over gm by small r. Further that small r can be replaced by r plus h. Again when h is negligible, when then v becomes root over gr. Now I am going to compare the satellite velocity. What is Vs? Satellite velocity. Do you know what is Ve? Escape velocity. Escape velocity formula root over 2gr. Satellite orbital velocity. Satellite revolving in orbit only. That's why this velocity is called as orbital velocity. Orbital velocity formula root over gr, whereas escape velocity root over 2gr. Which one is the greatest value? Escape velocity. Because of in escape velocity, along with G and R, we are having multiplication of 2. Alright? Now tell me which velocity is greater. Escape velocity is greater than orbital velocity. That means no satellite velocity should exceed escape velocity. Ella satellite velocity is lesser than escape velocity. Why? Otherwise it will move away from Earth gravitational pull. Then it won't give any information regarding the Earth surface. So in order to revolve any satellite around the Earth, their orbital velocity or parking velocity, their parking velocity should be lesser than escape velocity. Escape velocity equation root over 2gr. Orbital velocity root over gr. I just compare. Whenever you want to compare two value, just divide it. So I have divided v value and v value so that we are getting root 2. Again v is equal to v naught into root 2. In other words, we can say v naught is equal to v by root 2. Compare v naught and v, which one is greater? Ve is greater than v naught. Okay, tell me what is v naught? Orbital velocity. Ve, escape velocity. So the escape orbital velocity for satellite which is revolving closer to the Earth's surface, given by the formula root over g area. What about the small g value? Small g value 9.8. Okay, nearer to the Earth's surface. You have considered satellite is revolving nearer to the Earth's surface. Nearer to the Earth's surface, g value is 9.8. You know very well radius of Earth. How much? 6,400 kilometers. When you substitute the respective value, the orbital velocity approximately comes 3.2 kilometers per second. You know very well escape velocity. Escape velocity 11.2 kilometers per second. Escape velocity orbital velocity lesser. This is our velocity. Satellite velocity. Satellite orbital revolving the speed 3.2 kilometers per second. Whose pencil this? Huh? Micro pencil. So far we know about micro tip pencil, but it is called as micro pencil. Keep it safely. So orbital velocity 3.2 liya, escape velocity 11.2. Then compare pannomna, escape velocity is 44 times greater than orbital velocity. So the every 44 la varudhu, பிரச்சனை ஒரு calculation இருக்கு, அதே explain பண்றேன். Write the next title, time period of satellite. Time period of satellite. Time period of satellite. Okay, tell me, what is time period? Time taken to complete one revolution around the earth by satellite. So satellite is revolving around the earth, yeah? So the satellite one revolution complete pandradhukku how much time it will take? That is called as time period. So now I am going to relate time period formula in terms of velocity. Velocity formula or speed formula. Speed is equal to distance by time taken. Now time taken is nothing but time period. Time period means how much distance will be covered by satellite. Stop writing. Time period means how much distance will be covered by satellite. One complete circle. One complete circle is nothing but circumference. So that we can say 2 pi r is nothing but distance coverage. With the speed of v, satellite completes one rotation. Here we need the expression for time period. So time period t is equal to 2 pi r by v. What is r? R plus h. R is small. Small r is nothing but radius of orbit nu sollaam. Illana distance between the center of earth to satellite. Tell me what is capital R? Radius of earth. H. Distance between the earth surface to satellite position. Small r. Distance between the earth center to satellite location. That small r is equal to capital R plus h. Okay, now the small r value is replaced by r plus h whole divided by v. V expression already we know, yeah. What is the v basic expression? Root over. Yes, root over gm by small r. Again that small r can be replaced by r plus h. So that the equation becomes 2 pi r plus h by root gm. This root r goes in numerator. So root r can be written as r power 1 by 2. Right? Square root can be written as r power 1 by 2. Further the small r can be replaced by again r plus h. When base are same, powers can be added. 1 plus 1 by 2, 3 by 2. Again I am going to say when h is very small, h is very small, then h can be neglected. That means the term gm can be written as, first we can say r plus h power 3 by 2 whole by root gm. Okay, wow. Any planetary motion or satellite motion obeys Kepler's law of period. Kepler's law of period enna solluvaanga, t square is proportional to r cube. Whether the condition is satisfied or not nu check pannalama. Ready check pandradhupa. Take square on both sides because of t square is proportional to r cube laya. Our t irukku, if we need a t square means take square on both sides. When I take square on both sides, I will throw the duster on you. If you are going to start to disturb me means I am ready to disturb you. Okay, take square on both sides. So t square is equal to, by taking square on both sides, 4 pi square. If I take square for this term means r plus h power cube will come by gm. What is g? Acceleration due to gravity or gravitational constant. Whether it is a constant value or variable for everywhere. What is capital M? Mass of the source planet. Okay, satellite to satellite mass will be variable. But earth mass fixed. நம்ம send பண்ற satellite mass என்ன ஆகுமா? alter ஆகுமா? That means your mass of the earth or mass of the planet is constant. Capital G constant. Number 4 pi square. All these values are constant. When we remove these constant, we can say t square is proportional to r plus h whole cube, or simply we can say t square is proportional to r cube. We are just verifying whether satellite motion obeys Kepler's planetary motion or not. Obey பண்ணிருக்கா? Yes, obeying. Now come to this expression, satellite or time period formula. What is time period? Time taken to complete 1 revolution by satellite. That can be calculated by the formula. 2 pi r plus h power 3 by 2 root over gm. Tell me what is capital M? Mass of planet or mass of satellite? Mass of planet, not mass of satellite. So time period does not depend on mass of satellites. It purely depends on mass of the planet. Okay, va? That means smaller size satellite or bigger size satellite, no issue. That means heavier satellite or lighter satellite. Satellite mass will not play important role in the calculation of time period. Time period calculate பண்றப்ப satellite mass எந்த impactையும் create பண்ணாதான். The only impact obtained from mass of planet. Under the title time period of satellite, first write what is time period. What is time period? Time taken to complete one revolution around given planet. Time taken by any planet, by any satellite, time taken by any satellite to complete one revolution, around any planet. Write this expression alone. Box பண்ணிருக்கோம் இல்லையா? Write that expression alone. It concludes that from this equation என்ன conclude பண்றோம்பா? T does not depends on mass of satellite. It concludes that T does not depends on mass of satellite. Now time period for polar satellite. So far generally we discussed time period for any satellite. And now we are going to calculate the time period for a specified type of satellite. Specified type, first type name, polar satellite. Polar satellite will revolve around the pole, listen, going in. So around the earth இந்த மாதிரி up and down, இந்த மாதிரி revolve ஆகும் இல்லையா? Such kind of planets, such kind of satellites are known as polar satellite. Polar satellite actually located very shortest height from the earth surface. எர்த்தோட சர்ஃபேஸ் வந்து ஷார்ட் ஹைட்ல இருக்குமா. அப்ப அந்த மாதிரி சிச்சுவேஷன்ல ஈக்குவேஷன் becomes h is negligible. Satellite இங்க இருக்குன்னா h tends to 0 னா this equation becomes, இந்த equation h tends to 0 னா further we can say t is equal to என்ன எழுதலாமா 2 pi r power 3 by 2 whole divided by root over gm. The term gm can be replaced by gm பதிலா என்னலாம் many times we discuss small g is equal to gm by r square. So g into capital M can be replaced by gr square. Then root gr so root gm can be replaced by, yes tell me, root g into r. Then r goes in numerator, r power minus 1, 3 by 2 minus 1, 1 by 2, r power 1 by 2 by root g. R power 1 by 2 can be rewritten as root r by root g. Now tell me what is T? Time period for which kind of satellite? Polar satellite. So polar satellite time period given by the formula, all these values are approximate only. நம்ம h என்னன்னு சொல்லிட்டோம்பா, negligible. The real equation is this one. இதான் real equation. இப்போ approximate polar satellite னா எர்த்துக்கு நியரஸ்டா இருக்கும். h tends to 0 நம்ம approximate ஆ calculate பண்ணிட்டே இருக்கோம். In problem part you must use this equation. ஓகேவா? h neglect பண்ணாம செய்யணும். இது just வந்து ஒரு கம்பேரிசன்காக தான் இந்த மாதிரி ஸ்டடி பண்றோம். Okay, tell me what is r? What is r? Radius of earth. How much pa? 6400 kilometer. Kilo means 10 power 3. Small g value 9.8. That can be replaced by 10. 2 pi value 3.14. So by substituting all the values, you will get the answer 84.6 minutes. 84.6 minutes. Okay va? That means 4 hours satellite ஒரு revolution complete பண்ணா எவ்வளவு டைம் எடுக்குமா? 84.6 minutes. Tell me what is 84.6 minutes? Time taken by the polar satellite to complete one revolution around Earth. Okay va? Formula T is equal to 2 pi root over R by G. What is R? Radius of Earth. Here source planet is nothing but Earth. Earth தான் source. அது பேஸ் பண்ணி தான் மற்ற எல்லா பிளானட்ஸ் ரிவால்வ் ஆகிட்டே இருக்கு, நம்ம பேசிட்டே இருக்கோம். ஓகேவா? நெக்ஸ்ட் we are going to discuss about, இப்போ டிஸ்கஸ் பண்ணது என்னது? போலார். நெக்ஸ்ட் ஒன் geostationary satellite. Do you know the characteristics of geostationary satellite? இப்போ இதான் எர்த்னு அஸ்யூம் பண்ணிட்டோம்னா, நான் am going to assume this cube as a earth. இந்த பாயிண்ட்ல இந்த கலர் சாக்லேட்ஸ் இருக்கு இல்லையா, இதுக்கு ஆப்போசிட்ல இங்க ஒரு ஆர்பிட் இருக்குன்னா இந்த ஆர்பிட்ல தான் என்ன ரிவால்வ் ஆகும்பா? Geostationary satellite. இந்த ஆர்பிட்ல என்ன ரிவால்வ் ஆகும்? In vertical circle which satellite revolve? In horizontal circle which satellite will revolve? You know very well this great horizontal circle name என்னதுப்பா? Equator. இந்த great circle ஓட நேம் என்னது? Equator. Equatorலாம் எது ரிவால்வ் ஆகிட்டே இருக்குமா? Geostationary satellite. Now Earth is in rest condition or rotational condition? Rotational condition. Earth will take how much time to complete one rotation? I am not talking about revolution. Earth will take how much time to complete one rotation? 24 hours for one complete. Okay, if Earth completes half rotation means how much time will be taken? இங்க இருக்க அந்த கலர் பாயிண்ட் அப்படியே பேக் சைடு வந்திருக்குன்னா how much rotation is completed? Half revolution. Half revolution means how much time? 12 hours. At the same time the geostationary satellite சொல்றோம் இல்லையா, அந்த satellite இங்க இருக்குன்னா மேபி எர்த் ஒரு 90 டிகிரி டர்ன் ஆயிருக்குன்னா geostationary satelliteம் 90 டிகிரி டர்ன் ஆகும். எர்த் ஒரு 180 டிகிரி டர்ன் ஆயிருக்குன்னா geostationary satelliteம் 180 டிகிரி டர்ன் ஆகும். அப்ப என்ன மீன் பண்றேன்பா, இந்த பாயிண்ட்க்கு ஆப்போசிட்ல geostationary satellite இருக்குன்னா நெக்ஸ்ட் எர்த் இப்படி டர்ன் ஆச்சுன்னா satelliteம் இங்க வரும். எர்த் மேபி இப்படி டர்ன் ஆச்சுன்னா satelliteம் அதே மாதிரி பேக் சைடுல இருக்கும். அப்ப எர்த்துக்கு எக்ஸாக்ட் ஆப்போசிட் எண்ட்ல என்ன இருக்குமா? ஜியோஸ்டேஷனரி சேட்டலைட். எர்த்தோட சேர்ந்து எது ரிவால்வ் ஆயிட்டே இருக்குமா? ஜியோஸ்டேஷனரி சேட்டலைட். எர்த்துக்கு முதல்ல இந்த எண்ட்ல சேட்டலைட் இருக்குன்னா கடைசி வரைக்கும் எங்கடா இருக்குமா? இதுக்கு எக்ஸாக்ட் ஆப்போசிட் பாயிண்ட்ல இருக்கனால சேட்டலைட் அப்பியர்ஸ் அட் சிங்கிள் பாயிண்ட். சேட்டலைட் அப்பியர்ஸ் அட் சிங்கிள் பாயிண்ட். ஒரே இடத்துல இருந்தா அதுக்கு பேர் என்னதுப்பா? ஸ்டேஷனரி. That's why these kind of satellites are known as geostationary satellite. If Earth complete half rotation, geostationary satellite also complete half rotation. If Earth completes 30 degree rotation, geostationary satellite 30 degree rotation complete பண்ணுமா? Now tell me what is the time period for geostationary satellite? 24 hours. Why? Earth will take 24 hours to complete one rotation. அப்ப geostationary satellite 24 hours time will be taken. இங்க calculate பண்ணிருக்கிறது polar satellite. ஓகேவா? இப்போ நான் பேசிட்டே இருந்து geostationary satellite. Geostationary satellite take how much time to complete one revolution? 24 hours. Where polar satellite? Now tell me which satellite speed is high? Polar satellite. Because of it takes just 1 hour 15 minutes. அந்த மாதிரி தானே? Approximately 1.5 hour அப்படின்னு வச்சுக்கலாமா? 1.5 hourல ஒரு ரொட்டேஷன் கம்ப்ளீட் பண்ணிடலாம். அதே ஜியோஸ்டேஷனரி சேட்டலைட் தான் 1 day ஆகும் ஒரு ரொட்டேஷன் கம்ப்ளீட் பண்றதுக்கு. அப்ப எதுமா ஃபாஸ்டா ரொட்டேட் ஆகுது? போலார் சேட்டலைட். எழுதிக்கோங்க டைம் பீரியட் ஃபார் போலார் சேட்டலைட். Time taken for polar satellite. Why geostationary satellites are called so. இதுதான் அப்படி சொல்றோம்பா. Since that satellite position appears to be stationary with respect to Earth. What about its velocity relative to Earth? Listen. What is the relative velocity of geostationary satellite? 0. ஏன்னா relative velocity என்னதுப்பா? Velocity of satellite minus velocity of Earth. Both values are same. Our relative velocity of geostationary satellite is 0. What is VAB? How will you read this? VAB எப்படி read பண்ணுவார்? Velocity of A with respect to B. A and B பதிலாக தான் geostationary satellite and Earth னு எடுக்கிறோம். Both system velocity is same. Our relative velocity பார்த்தோம்னா 0. The relative velocity of geostationary satellite is 0 with respect to Earth. எழுதிக்கோங்க. Time period for polar satellite. Time period for polar satellite. இல்லையாச்சா? 84.6 minutes. And time period for geostationary satellite 24 hours. 84.6 minutes for polar satellite, 24 hours for geostationary satellite. மாறி சொல்றேன் அதுக்கு முன்னாடி கரெக்டாக தான் சொல்றேன். Next one, parking distance or parking height of geostationary satellite. Parking distance. Parking distance of geostationary satellite. Okay, listen, again assume this box as here, Earth. Stop writing. The box na Earth na, the equator region la inner revolve aite irukuma. Inner satellite, geostationary. The geostationary satellite is located at a distance of, this is Earth surface. The inner surface, Earth surface. Earth surface la inner geostationary satellite, evlo distance nama locate pananum. That is called as H. We are going to calculate this H value using the time period formula. Time period formula T is equal to 2 pi R plus H root over GM liya. Okay, tell me what is T value? Time period for geostationary satellite 24 hours. 24 hours means how many seconds? 86,400 seconds. 86,400 seconds. So this value is 86,400 seconds. 2 pi value, you know very well R value. What is R? Radius of Earth, 6,400 kilometer. Capital G value, 6.61 into 10 power minus 11. Capital M, mass of Earth, how much? 6 into 10 power 24 kilogram. By substituting all the values, we can easily identify H value. Correct, Alia? H value எப்படி calculate பண்ணலாம்? Take square on both side. Square பண்ணோம்னா என்ன வருமா? T square 4 pi square R plus H whole power 3 by GM. So T square GM by 4 pi square, that is equal to R plus H the whole cube. By taking cube root on both sides, we can say R plus H. Correct? Cube root entering. Further taking the plus R value this side minus R, we can get H formula. So H na enadpa parking distance for its satellite, geostationary satellite. H value given by this formula. Title என்ன எழுதிருக்கீங்க? Parking height தானே. So parking height னு சொல்லிட்டு write this expression. Okay, complete பண்ணிடலாம். அதுக்கப்புறம் எழுதலாம். Listen a minute. So when we substitute all these values, we are getting the H value as, the H value எவ்வளவு வரும்னா 36,000 kilometer. ஸோ எர்த்தோட சர்ஃபேஸ்ல இருந்து இந்த சேட்டலைட் எவ்வளோ டிஸ்டன்ஸ்ல பார்க் பண்ணியிருக்காங்களா 36,000 கிலோமீட்டர். எர்த்தோட சென்டர்ல இருந்து எவ்வளோ டிஸ்டன்ஸ்பா? எர்த்தோட சென்டர்ல இருந்து கேட்டா இந்த ஹெச்சோட எதை ஆட் பண்ணணும்? ஆர் வேல்யூ 6,400 கிலோமீட்டர். அதை ஆட் பண்ணி சொன்னா 42,400 கிலோமீட்டர். அவ்வளோ ஹைட்ல லொகேட் பண்ணி வச்சிருக்கோமா எந்த சேட்டலைட்ட? எந்த சேட்டலைட் ஃபார்வேல இருக்கு? எது நியரஸ்டா இருக்கு? போலார் சேட்டலைட். ஓகேவா? எழுதிக்கோங்க. பார்க்கிங் ஹைட் ஃபார் ஜியோ ஸ்டேஷனரி சேட்டலைட். Parking height for geostationary satellite after copy that equation, write the sentence by substituting all the known values. By substituting all the known values, H becomes 36,000 kilometer. Kilometer. Next topic, angular momentum of satellite. Angular momentum of satellite. Satellite is involved in which kind of motion? Straight line motion or circular motion? Circular motion. Circular motion means definitely it possesses angular momentum. Angular momentum symbol L. L formula MVR. What is M here? Mass of satellite. எது rotational motion இருக்கு? Satellite. அதோட angular momentum தானே? அப்ப M stands for mass of the satellite. டைட்டில் என்ன எழுதிருக்கீங்கம்மா? angular momentum of satellite L is equal to MVR. M nothing but mass of satellite. What is V? Velocity of satellite. What is the basic expression for velocity? Velocity basic expression root over Gm by small r. Small r can be replaced by r plus h into small r. The small r retain பண்ணிட்டேனா you can say Gm. This r can be written as root r square. Right? Why we are doing like that? To cancel this small r with this r square. The final equation becomes root over Gm r square by r. R. So angular momentum of satellite. Angular momentum of satellite formula M root over Gm small r. There is a highlight point. So far we say time period purely depends on mass of satellite or mass of planet. Then velocity of satellite also depends on V is equal to root over Gm la capital M na enadhu mass of the planet. So velocity of satellite and the time period of satellite does not depends upon mass of satellite. புரியுதா? Velocity, time period does not depends on mass of satellite. Whereas angular momentum depends on mass of the satellite as well as mass of the planet. ரெண்டுமே வருது பாருங்க. From which we can say L is proportional to root r. Angular momentum and r is directly proportional. எழுதிக்கோங்க. Angular momentum of satellite from the above equation it is concluded that L depends on both the satellite comma planet mass. Both the satellite and the planet mass. next one, energy of satellite. So far என்னென்ன content பார்த்திருக்கோம்பா? Hey, velocity, time period, angular momentum. The next one is energy of satellite. Yes, energy of satellite. Okay, any moving system or any system with respect to their position, we can say their energy into two categories. One is kinetic, another one is potential energy. Generally, mechanical energy classified into two categories: potential and kinetic energy. Kinetic energy belongs to moving character. Potential energy belongs to shape and position. When the satellite or position, Earth or surface, it is located far away from Earth's surface. So based on that position, we can say satellite possess potential energy. Gravitational potential energy formula. If you are having two objects like M1 and M2 are separated by distance r, what about its potential energy? Minus G M1 M2 by small r. R square will come. R square will not come. R alone will come. Force formula G M1 M2 by R square. Okay, in this situation, tell me what is M1, what is M2? Mass of the planet, mass of satellite. Small r can be replaced by r plus h. Let us small r away retain manika. No issue. The first expression says potential energy. In energy, potential energy. Further, we can replace the Gm value. Gm value with Gr square. Let us update it. Next, we are going to calculate kinetic energy. Kinetic energy general formula half mv square. What is v? Velocity of satellite formula root over gm by r. That is v formula. Here we need v square. So what will come? Gm by small r. Again kinetic energy formula g mm by 2r. Now compare kinetic energy and potential energy. Potential energy available in minus, whereas kinetic energy available in plus. What is the difference? Except that sign. In both equations, we are having G, small m, capital M, small r. The kinetic energy like denominator we are having 2, whereas in potential energy we are not having that 2. Okay, what is the ratio of potential energy and kinetic energy? When we divide these two, we can get its ratio. In our minus 1. Here we are having plus 1 by 2. All other things will get.
Standard 10. Relating to September monthly test, review or performance of papers will be conducted by the chairman today by 4:15. 4:15 p.m. in the office room. All such teachers should assemble in the office by 4 p.m. itself. Thank you.
Okay, just to divide potential energy and kinetic energy, see here. So when you divide these two equations, except minus and 1 by 2, everything gets cancelled. So U and K ratio enna solvanga? Minus 2:1. 2 will go to numerator. Open your mouth. Minus 2:1 is the ratio for potential energy and kinetic energy. By doing the cross multiplication, we can say U is equal to minus 2K. Purida. Now we are going to calculate total energy. Total energy means sum of potential energy and kinetic energy. Now the term potential energy can be replaced by minus 2K. Already we are having 1 plus K, so that minus K. So minus K means write this equation with minus sign. Minus Gmm by 2R. This is the expression for total energy of satellite. So far we discussed regarding three kind of energy. First one, potential energy. Next one, then total energy. First ratio, U and K. U potential, K kinetic. The second ratio, total energy and kinetic energy ratio. Total energy and kinetic energy. Just take the k value this side. அப்ப என்ன remaining இருக்கும்பா? -1. Correct? Total energy and kinetic energy ratio -1:1. Potential energy and kinetic energy ratio -2:1. Then total energy and potential energy ratio. Whenever you need ratio, you just divide both the equation. Total energy equation minus gmm by 2r. Potential energy equation minus gmm by r. Except 1/2, all other thing gets cancelled, so that we can say 1:2. இது எதோட ratio? Total energy and potential energy ratio. Okay வா? எழுதிக்கோங்க. All the three equations and ratio should be written. Okay, now we are going to study about variation of energy with respect to distance r. Listen fast, stop writing. What is K? Kinetic energy. R, distance. Both are inversely proportional. So in x-axis I have taken distance r, y-axis line kinetic energy. Kinetic energy in positive or negative sign? Positive sign. Kinetic energy positive. But kinetic energy and distance is inversely proportional. Kinetic energy will be decreases with the increase in distance. Correct? In the arrow mark r value negative r value increases, kinetic energy k value decreases, since k and r is inversely proportional. Next we need the variation of potential energy and r. Potential energy in the format la irukku minus. Appo potential energy in the axis la irukuma minus. So minus la pick panniyaachu. Again u and r is inversely proportional. Potential energy graph will come in this manner. Okay va? Then total energy and distance r. Total energy and distance r. Again adu enna proportional na? Inversely proportional. Adu edhula da irukku negative. So this is the graph for total energy. Why I have taken the total energy graph in this manner? Potential energy ஏன் கீழ எடுத்துருக்கேன். இது ரீசன் இருக்கா? கண்டிப்பா ரீசன் இருக்கு. என்ன ரீசன் டிஸ்கஸ் பண்றதுக்கு முன்னாடி கிராஃப் முதல்ல பிளாட் பண்ணிக்கோ. ஒரு டேட்டாவோட இந்த கான்செப்டை நான் டீச் பண்றேன். இதுல எந்த டவுட்ஸும் வராது. ஏன் ஃபர்ஸ்ட் பொட்டன்ஷியல் எனர்ஜி டோட்டல் எனர்ஜி எடுத்து நெக்ஸ்ட் பொட்டன்ஷியல் எடுத்துருக்கேன், அதுக்கு ரீசன் இருக்கு சொல்றேன். Listen ba. So in the graph first one edu last varum. Adu explain pandrukku I have taken r value as 1. So in the graph the value la vandu g m m idella just ஒரு 1 ன்னு எடுத்துக்கேன். கான்ஸ்டன்ட்டா just study பண்றதுக்கு. அப்ப r value என்ன பிக் பண்ணிருக்கேன்? 1. then U is equal to minus 1 by 1, that is equal to minus 1. இதே total energy என்ன வரும்பா? I have taken all G, M, N values 1. The smaller value 1 mark பண்ணினா what answer will come? Minus 1 by 2. Similarly, R is equal to 2. R is equal to 2 na இந்த expression 2 mark பண்ணோம்னா minus 1 by 2. இதே total energy என்ன வரும்பா? Minus 1 by 4. Similarly, R is equal to 3 னு mark பண்றேன். Minus 1 by 3, minus 1 by 6 வந்துரும். எல்லா மைனஸையும் விட்டுருங்க. Which variation occurs fast? எந்த வேரியேஷன் ஃபாஸ்டா இருக்கு? பாருங்க R வேல்யூ ஸ்லோவா என்னாயிட்டே இருக்குப்பா? இன்க்ரீஸ் ஆயிட்டே இருக்கா? 1 2 3 னு. பொட்டன்ஷியல் எனர்ஜி டிக்ரீஸ் ஆகுது. பாருங்க இது 1 0.5 0.33 1 0.5 0.33. whereas total energy பாருங்க 0.5 0.25 0.16. அப்பனா எதுப்பா ஃபாஸ்டா டிக்ரீஸ் ஆயிருக்கு? டோட்டல் எனர்ஜி. இது ஸ்லோவா தான் டிக்ரீஸ் ஆயிருக்கு. பட் இது எப்படி டிக்ரீஸ் ஆயிருக்கா? ஃபாஸ்டா டிக்ரீஸ் ஆகும். எது ஃபாஸ்டா டிக்ரீஸ் ஆகுமோ அந்த கிராஃப் தான் ஃபர்ஸ்ட் வரும். எது ஃபாஸ்டா டிக்ரீஸ் ஆகுமோ அதான் மோர் ஸ்டீப்பரா இருக்கும். இந்த ரெண்டு கிராஃப்ல எது மோர் ஸ்டீப்பர்னு கேட்டா இதான் மோர் ஸ்டீப்பர். எப்படி சார் சொல்றீங்கன்னா you have to draw one tangent. ஒரு tangent draw பண்ணீங்கன்னா இந்த tangent தான் ரொம்ப ஸ்டீப்பரா இருக்கும், இது லெஸ் ஸ்டீப்பரா இருக்கும். எது மோர் ஸ்டீப்பரா இருக்கும் அந்த வேரியேஷன் will be larger. ஓகேவா? அப்ப E U ல எதுப்பா ஃபர்ஸ்ட் வரும்? E graph. Then only U graph will come. புரியுதா? So we have discussed up to variation of energy with respect to distance. Remaining things, that means problem will be discussed in tomorrow's class.